Hello friends, welcome in my channel My Physics Easy Physics. In previous class we have discussed electric dipole and electric dipole moment, and we have also discussed electric field lines. Today I am going to discuss electric field due to an electric dipole. We know electric field due to a point charge, but today we are going to discuss electric field due to an electric dipole. So today's topic is electric field due to an electric dipole. Electric field due to an electric dipole. To consider an electric dipole, here it is minus q charge, here it is plus q charge. This is minus q, this is plus q, and both the charges are placed small distance apart. Both the charges are placed small distance apart. This point is A, this point is B. Here it is the center of electric dipole. This is the center of electric dipole. And we know that the direction of electric dipole moment is from minus charge to plus charge. Direction of electric dipole moment is from minus charge to plus charge. We have to find electric dipole moment of this electric dipole. That will be given by P equals to magnitude of either charge, that is Q, and distance between them. Distance between them is generally we are denoting by D, but here for simplicity of calculation I am denoting distance between these two charges as 2D, so that from center it is D, from this center it is also D. Therefore here it will become Q into 2D. Distance we have assumed as 2D instead of D, and direction will be from A to B. Direction will be from A to B. This is electric dipole moment, direction from A to B. Now while using this electric dipole, we have to find out electric field intensity at different points. For the first case, we considered that the point P is on axial line of the dipole. This line is known as axial line of the dipole. Here it is our point P. At that point P, we have to find out electric field intensity or electric field. It means here in case first, this point P may be on axial line, this point may be on equatorial line. This line just perpendicular to the direction of electric dipole moment is known as equatorial line. In first case, we find electric field intensity just on axial line, then we find electric field intensity on equatorial line, and we can then find the formula for at any point also. So first of all, I am discussing that when point P lies on axial line. When point P lies on axial line. When point P lies on axial line. So here this is axial line. This point is P. From definition of electric field, we know that force experienced by a unit positive charge is defined as electric field intensity. It means here we have considered a unit positive charge. At point P there is unit positive charge. This is also a positive charge. Therefore, electric field at point P due to plus Q charge, which is situated at B, will be in this direction. This is EB. Electric field at point P due to plus Q charge situated at B will be denoted by EB. But similarly, this A is minus Q charge, or at point A there is minus Q charge. this minus q charge will attract point P, or in other words we can say that at point P direction of electric field due to minus q charge at A will be EA, but the direction is opposite. Now from this diagram it is clear that EB and EA are opposite to each other. First of all, I am writing the expression for EA and EB, and for this we must have distance from P to B, we must have distance from P to A. Here we have denoted only 2D distance, that is between point A and B. Now let us suppose the point P is at a distance R from center of the dipole. You should keep in mind this point. R we have considered the distance of point P from center of the dipole. Now we can easily calculate BP and AP. If we want to write BP, it will be R minus B. If we have to write AP, it will be R plus B. Therefore, I am writing here EA. We know that the formula of electric field is KQ by R square, where R means the distance of point P from the source charge. Here source charge is minus Q. This is at point P. Therefore, we will write KQ by AP square. And in the expression for electric field, you need not to write the minus sign. इलेक्ट्रिक फील्ड की वैल्यू लिखते वक्त आपको माइनस साइन नहीं लेना है, बिकॉज द रोल ऑफ माइनस विल बी इन द डायरेक्शन. द डायरेक्शन विल बी अलोंग PA. The direction of EA will be along PA. It means P to A KQ by AP square, or that we can also write KQ by, now AB is D. This distance is R from the center of dipole. Therefore, this is D, this is D, and here it is R. That's why AP will be R plus D. Therefore, EA can be written as KQ by AP square or KQ by R plus D square, but the direction is along PA. Let us suppose this is equation number 1. Similarly, we write electric field due to point B. EB. From this diagram it is very clear. EB can be written as KQ by BP square. KQ by BP square. And now since AP can be written as R plus D, similarly this BP can be written as R minus D. EA KQ by R plus D square, EB KQ by R minus D square, and the direction is along BP. It means both are oppositely directed. Now we have to use the concept of vector to find the resultant of these two electric fields. It is clear that EB is opposite to EA. It means if we have to find the resultant of EA and EB, first of all we have to see which is having higher magnitude. And from this diagram or from this equation, it is very clear that EA equals to KQ by R plus D square and EB equals to KQ by R minus D square. Here denominator is high, here denominator is less. Therefore, if we find the magnitude, then we get that the magnitude of EB will be greater than magnitude of EA, and therefore net electric field at point P will be the subtraction of EB and EA. Now I am removing this diagram. We are finding on axial line, therefore we can represent as E axial equals to EB minus EA. EB minus EA. We can put the values from equation 1 and 2. Now when we put the value, it is clear that KQ and KQ both are common. Therefore we can write KQ into 1 by R minus D square minus 1 upon R plus D square. And the final direction will be of EB only. Therefore we can write along BP. The net electric field will be along BP. Now you know the basic formula A plus B whole square, A minus B whole square. By using this formula, we can write R plus D whole square, R minus D whole square. And here we can say R minus D whole square into R plus D whole square. Now after solving, it is clear that KQ R plus D whole square, it means first term will be R square, second term will be D square plus 2RD minus R square plus D square minus 2RD. And in numerator, we can use the identity A minus B into A plus B, that is A square minus B square. Therefore, we can write R square minus D square whole square. In the numerator, most of the terms have been cancelled out. R square cancel out. D square cancel out. And 2RD and minus of minus 2RD, that will become 4RD. Therefore, we can write KQ into 4RD divided by R square minus D square whole square. And this is along BP, this is also along BP, and this is also along BP. Direction we have to mention clearly. Now from this expression KQ4RD, we can separate 2QD, because for this dipole we have already assumed that electric dipole moment is 2QD, because distance we have assumed as 2D. Therefore I am separating these two terms. 2KR separate and 2QD separate, divide by R square minus D square whole square, and that is also along BP. Now from previous diagram of electric dipole on axial line, it is clear that the direction of electric dipole moment is just similar to the direction of electric field. Direction of electric field is along BP, and the direction of electric dipole moment is also in this direction. Therefore, this 2QD can be written as P in vector form. So finally, we can write E axial equals to 2KRP divided by R square minus D square whole square. This is our final expression. E axial equals to 2KRP divided by R square minus D square whole square. Since distance between two charges is very small, therefore generally we can assume that it is not always, keep in mind it is not always, but generally we can assume that distance R is greater than D. Therefore in the term R square minus D square can be neglected. Therefore we can assume this assumption R square minus D square nearly equals to R square. Therefore E axial becomes E axial equals to 2KRP divided by R to the power 4, because this is R square and whole square. And finally we can write 2 Kp divided by R. This is electric field on axial line of an electric dipole. But in which condition? When R is greater than D. It means this formula is having some assumption. But this formula E axial equals to 2KRP divided by R square minus D square is whole square is not having any assumption like this. Thank you.